Here we go. So guys, what we're going to do today, well, actually, never mind. Let's date and title your notes, and I've got a better way to explain to you what we're doing today. So guys, the date today appears to be the 11th. Amazingly, it's like our first days of school in April, and the month is already a third over. Kind of crazy. But guys, the date today is the 11th, and the topic for your notes today is stoichiometry. Oh yeah, stoichiometry. So part of your homework tonight is going to be to go home, and if you eat dinner with family members or whomever, around the dinner table, you want to say out loud, guess what I learned today? And then you can say stoichiometry. And then you're going to sound intelligent around the dinner table. And whoever's with you will have a whole new respect for what you do at school. But guys, at the end of the day, what is stoichiometry? Guys, do not write this down, but watch. Guys, stoichiometry is the bringing together of skills that you have already developed. So these are the skills. Guys, skill number 1 is doing moles conversions. Guys, that was the last unit. Many of you did very well on this, but for those of you that didn't, and you're in the middle of remediation, guys, there's only one essential from that unit. Convert grams to moles or moles to grams. Guys, Avogadro's number is gone, molarity is gone, all of those conversions are gone. So guys, when we talk about moles conversions, all you got to be able to do is go grams to moles or moles to grams, and both of those involve the formula mass. So guys, that's skill number 1. Skill number 2 is balancing equations. We've now done 2 days of balancing equations. So guys, this is a skill that we've been recently developing. But guys, when you bring moles conversions and balancing equations together, that is what stoichiometry is. Guys, stoichiometry is the math of chemical reactions. And guys, this is a skill. This is not a concept. This is something you've got to be able to do. So guys, here's how today's going to go. There's one idea that you need to understand, but guys, do not take notes. One idea that you need to understand, then I'm going to give you the steps for solving these problems, then we're going to go 2, we're going to practice on 2, and then you're going to get your homework largely done today. You guys ready to go? Guys, it goes like this. Do not write this down. So guys, when we talk about stoichiometry, what we are really looking for are what are called stoichiometric ratios. So guys, don't write this down, but a stoichiometric ratio is a molar ratio of one reactant or product to another reactant or product. So it is a ratio of reactants to products. Now guys, we get these from balanced equations. You ready? This reaction has a stoichiometric ratio of 1 to 3 to 2. Do you now understand stoichiometric ratios? Guys, that's all there is to it. 1 mole of nitrogen goes in, 3 moles of hydrogen reacts with it, and 2 moles of NH3 come out. You get the idea? Guys, that's all there is to stoichiometric ratios. So let's make sure. This is the combustion of methane, which is Bunsen burner gas. Guys, what are the stoichiometric ratios? 1 to 2 to 1 to 2. Do you now understand stoichiometric ratios? Okay. So guys, with that said, we're going to use these stoichiometric ratios to solve problems. This you want to write down. Ready? So guys, when we solve these things, what we're going to be solving are what are called mass-mass problems. So guys, you don't need to write the definition to this. You just need to understand that stoichiometry is a really big discipline in chemistry, and we're only going to solve one type of stoichiometric problem, which are what are called mass-mass problems. So guys, again, please don't write down the definition, but read through it with me. So guys, the fundamental idea is this. A mass-mass problem starts with a mass, and it ends up with a mass. So this is the technical definition. Just read it with me. Mass-mass problem is a stoichiometric process that allows you to predict how much reactant or product will be consumed or created during a chemical reaction. So guys, it gives math to balanced equations. Here's how to solve them, and you want to write this down. This is the last of your notes. There's 4 steps. Guys, step number 1 is this: write a balanced equation. As I said, stoichiometry is the bringing together of balancing equations and moles conversions. So guys, step number 1 is write a balanced equation. Then at this point, step number 2 is to convert mass to moles. Hey, there's our moles conversions. But guys, it's a one-step process. Convert mass to moles. Then guys, step number 3 jumps back up to step number 1. Now we need to apply the stoichiometric ratio from the balanced equation. But guys, frankly, you could just write down, this would be enough. If you just write down apply ratio, that'll be plenty to remind you. So guys, step number 3 is to apply the ratio from the balanced equation. Then guys, step number 4 is back to the math, and you're going to convert moles to grams. So guys, that's why we call these mass-mass problems. In step number 2, you start with a mass. In step number 4, you end up with a mass. And guys, that's it. These problems work the same every single time. So guys, we're gonna practice on 2, and then like I said, you're gonna get your homework done today. Also, this is going to be a really good reconnection for you with balancing equations so that you're really ready to go do the lab on Thursday. So guys, are we all caught up? Can we solve a couple? You're okay? Okay. So guys, I don't know if you need, actually, you know, I think you're probably okay if you don't write this down. But guys, read it with me. So the question is this: if we burn, well, let's read it. How much water will be produced when 12 grams of methane are consumed in a combustion reaction? So guys, let's put this into context. So guys, methane is Bunsen burner gas. So if we turn on our Bunsen burner and if we burn 12.5 grams of methane, how much water will we make? Do you understand the question that we're asking? Then let's solve it. Guys, write the balanced equation for this reaction. You should be able to do this based on what we did previously. Do it in your notes. You've got about a minute. Guys, if you're not sure how to do this, remember our strategy. Draw an arrow in the middle of your paper. Then start going through the reaction. What are your reactants? And then once you've figured out your reactants, it's already told you it's a combustion reaction, which means you automatically know your products because the products of combustion are always carbon dioxide and water. And then balance it. So guys, take what you've got and share it with the person next to you. Come up with a consensus answer. Share your work, find each other's strengths, find each other's mistakes. Come up with a consensus answer for this balanced equation. Share your work. Guys, you got about 20 seconds. All right, so guys, let's talk about this. I think right now some of you are having the experience that explains why we're not going to lab today. And guys, understand that if we hadn't had spring break prior to this, you'd be in a much better space. But guys, I think some of you are looking at this and going, ugh, hang on a second. So again, this is good practice in preparation for Thursday's lab. So here's our reactants. Guys, write this down with me if you don't have it. CH4 is methane, and this is a combustion reaction. Combustion reactions always involve a reaction with oxygen, but remember oxygen is diatomic, so it's O2. Then guys, our products are always the same. Carbon dioxide and water. That never changes. Our products are always carbon dioxide and water. Then guys, at this point, we need to balance it. So we've got one carbon, we've got 4 hydrogens, 2 hydrogens. So we need a 2. And then here we've got 2 oxygens. Here we've got 2 and 4. 2 plus 2 is 4. So there we need a 2. So guys, if you were not able to get to this result, understand that you may be falling behind a little bit. And so guys, if you've been missing days, you need to get on top of those screencasts and get caught back up. But guys, understand that this is something that should have been within your realm of possible from what we've been doing the last couple days. But guys, if you don't have this, write it down. You need it. You got it? Okay, so now guys, let me share some strategies with you about how to solve this. I would really encourage you to do this with me. So guys, what you want to do now is go up to the question, find the data, and then write it underneath where it is in the reaction. So guys, for example, we've got 12.5 grams of methane. Write it down underneath the methane. This will keep you organized. Now guys, the other thing you want to do is this. You need to identify your goal. What are you solving for? Well guys, this says how much water, so I would encourage you to put a question mark under water. That then tells you your goal. Guys, now at this point, it's just bringing together stuff that you already know. So now we're going to do some converting. So guys, the first thing we need is a goal, but we already know that it's water. So off to the right, we're going to set our goal, grams of water. Then guys, we need a really big line. And that line will always contain 3 steps. So guys, make your line big enough to contain 3 steps. And now we need a starting point, but we've already identified what it is because it's the 12.5 grams of CH4. Now guys, at this point, there's actually a sub-step to the process, which is this. Big deep breath, sigh of relief. Because guys, if you can get to this point, it's the same stinking process every single time. Convert grams to moles, mole to mole ratio, moles to grams. Guys, every single time. So, guys, first thing we've got to do is convert grams to moles. I'm not going to spend the time to chat through that because either you know how to do it or you should be doing remediation. So guys, carbon is 12.0. Hydrogen to 3 significant digits is 1.01. We need 3 because there's 3 there. Add those up and you get 16.04. So guys, that's just converting to moles. And again, either you know how to do it or you should be doing remediation. Then guys, at this point, this is the new step. We need the mole to mole ratio. So guys, watch what we're going to do. We're in moles right here. We bring that down, but leave a blank. Blank moles of CH4. And then guys, on the top, we need moles of our product. But in this case, our product is water, so it's blank moles of water on top. Again, the step is bring moles of your starting point down and then put moles of your goal on the top. Then guys, we got to fill in the blanks. That's the stoichiometric ratio. What is the number in front of the CH4? CH4 is a 1. Write it down. And then guys, in front of the water, we've got a 2. Then guys, the last step is just the opposite of the first. Now we need to go moles to grams. So we bring down moles of water. Water weighs 18.02 grams per mole. Again, hydrogen is 1.01, oxygen 16.0. Do the math. Then guys, I'm just going to do the math for you. You know how to do this. Divide by the bottom, multiply by the top. And guys, the answer is 28.086. But then we've got to check significant digits. We've got 3, we've got 4, we've got perfect, we've got 4. So to 3, guys, that's 28.1 grams of CH, or of water. So if you're curious, because a gram is a milliliter if it's water, because we're talking about, yeah, that's pretty close. Guys, we're actually talking about this much water. But then the question is, how much is 12.5 grams of CH4? And I did the math last year, and I happen to remember. Guys, we burn 12.5 grams of CH4 if we run our Bunsen burners for about 15 minutes. So if you run your Bunsen burner for 15 minutes, that's the amount of water that you make. So, guys, questions about the process? Again, this is all process. It works the same every time. Anything you want to talk about? We're going to do one more and then you're going to get going on homework. So guys, the question is then, oh shoot, actually I added this. Let me show this to you. So guys, sorry, I forgot that I added this, and this might be helpful. So guys, we obviously just got done solving this thing. And we talked about the idea that the steps are always the same. But guys, literally, these are always the steps. You start with a mass, you end up with a mass, and then you convert grams to moles using the formula mass, then the mole-to-mole ratio from the balanced equation, and then you use the formula mass to go from moles to grams. Guys, they work like this every single time. So, with that said, let's do this one. Guys, again, I don't think you need to write it down, but let's work through this, and then you'll have lots of time to get your homework done. So it says this: how much copper 2 nitrate will be consumed when 10.2 grams of sodium chloride is reacted with it? So guys, let's talk through this. So we've got copper 2 nitrate. Is that a reactant or a product if it's being consumed? Is it a reactant or a product if it's being consumed? It's a reactant. So guys, we've got to figure out what this is, but we know it's going to be on the reactant side. So guys, we need charges. Copper is +2, nitrate is -1. Again, writing chemical formulas. So if this is +2 and this is -1, we need one of these and two of those, and that would be CuNO3 2. Now guys, this is being reacted with sodium chloride. And we know sodium chloride is our good friend table salt. Sodium's +1, chlorine's -1, and off we go. Alright guys, single displacement, double displacement, synthesis, decomposition, or combustion. Tell the person next to you what this is going to be. If you don't know, ask the person next to you what it's going to be. So guys, let's go through the options. Why can this not be single displacement? Because single displacement is an element and a compound, and this is two compounds. Guys, why can this not be decomposition? Just a second. Why can't this be decomposition? It's got more than one reactant. Decomposition breaks one thing apart. Why can't it be synthesis? Because there's no way we can shove all these things together. Why can't it be combustion? Because it's not a hydrocarbon and oxygen. So guys, what's left? Double displacement. Two compounds, and we'll find out in a minute they're trading partners. Go ahead.
The double displacement reaction, the single displacement reaction be the compound on a compound is one of the compounds would add like a polyatomic ion with positive charge? Like, could it be like ammonium and then a salt with, and then ammonium replacing the element
Yeah.
salt?
Yes, it could be. And again, guys, forgive me. I know I say this a lot now. What you're going to find out when we talk about these next year is that even with these double displacement reactions, there's actually only two characters that are doing chemistry, and the others are just hanging around watching. So yes to your question, and you're going to find out that they even simplify. They simplify even more than that. So yeah. You guys okay? Double displacement. So guys, in order to do double displacement, we need to trade partners. So the positive copper hooks up with the negative chlorine. But guys, watch. We've already established that copper is +2, and we've established that chlorine is -1. So when the copper hooks up with the chlorine, we need 1 copper and 2 chlorines, because copper is +2 and chlorine is -1. So guys, if you're looking at this right now and you're feeling a little overwhelmed, guys, this is one of those days that kind of finds the chinks in your armor. If you can't write chemical formulas, this may have been weird. If you don't know the reaction types, this could have been weird. If you don't understand how to predict the products of double displacement reactions, again, could have been weird. So guys, my advice to you is get caught up now. Watch the screencast, come and ask questions. I want to help you, but you need to do the work in advance. So we've got our one product. So then our other product is going to be the positive hooking up with the negative. But guys, we know that sodium is +1, and we know that nitrate is -1. And as a result, we need 1 sodium and 1 nitrate to form the other product. Now guys, we've got to balance the equation. 1 copper, 2 nitrates, 1 nitrate, so we need a 2. 1 sodium, 2 sodium, so we need a 2. And then that balances the chlorines as well. Thoughts to that point? You okay? Okay, now guys, at this point, again, sub-step A, big deep breath. This is where this becomes totally repetitious. So here's what we're going to do. We need to find the data. And we know we've got 10.2 grams of sodium chloride, so write it down underneath. We got 10.2 grams of sodium chloride, and now we need to know what we're solving for, but it says how much copper 2 nitrate. So that's our question mark. So now guys, at this point, set a goal. That would be grams of copper 2 nitrate. Draw a line. And then our starting point is 10.2 grams of table salt. So guys, if we throw 10.2 grams of table salt at copper 2 nitrate, how much copper 2 nitrate is going to be consumed when they react together? And guys, at this point, it's the same 3 steps. Grams to moles, moles to moles, moles to grams, every time. So let's convert grams to moles. So guys, sodium's 23.0, chlorine's 35.5, so 58.5 grams of NaCl is 1 mole. Guys, let me sort of warn you now. Make sure you're writing down the NaCl, because when I see you next Monday, it gets weird. Make sure that you're writing down the formulas for what you're talking about. Then guys, our new step, moles of NaCl comes down, moles of our goal goes on top. Then guys, I'll pause for a minute and let you fill in the blanks. So in front of the NaCl, we've got a 2. In front of the CuNO3, 2, we've got a 1. And then guys, the last step is to bring down moles of your goal, convert to grams, copper, nitrogen, it all adds up to 187.5. Do the math, round to 3 significant digits, and you're done. So guys, for some of you that might have felt rushed because you're like, wait, he's just clicking through stuff. But guys, the stuff that I'm clicking through is stuff that should be a part of your toolbox. Converting grams to moles, multiplying by the top, dividing by the bottom, rounding to the fewest significant digits. But guys, this is how these work. What I want to do is look at your homework with you for just a minute to get you oriented to what we're doing. And then guys, we're going to have a good amount of time for you to work on homework. Does anybody need a homework packet? You're good? Good? Okay. All right. So guys, looking at assignment number 3 with me really quickly. So guys, this is the way that this works. 4 steps, right? Balanced equation, grams to moles, moles to moles, moles to grams. In numbers 1 and 2, you are given the balanced equations. In numbers 3 and 4, you are not given the balanced equations. Then guys, in number 5 and 6, you are given the balanced equation, but it's the same balanced equation for 5 and for 6. Then guys, number 7 feels like it's out of left field until you figure out it's actually really helpful. It just says, identify the reaction types. But then guys, this is the good bit. You'll notice in 8 through 13, you're not given the balanced equations. They're all in number 7. So guys, you don't have to write the balanced equations for 8 through 13. You just need to figure out which balanced equation to use because they're not in order, but they're all there. So guys, we're going to go through number 13. You'll probably get this done today, I would think. So guys, the rest of the time is yours. The answers will be posted on the wall. Guys, on Thursday, we will review these and then we'll get into lab.